Okay, today we're going to look at section 5.1. Unit circle and basic trigonometry is the name of the unit. For this one, though, we're going to look at a circle. We're going to go back and look at what a circle is. We're going to do the generic one over here. I'm going to walk you through how the equation of a circle is generated and where it comes from. And so here we go. So if you just kind of walk us through the process. So we're going to draw a circle around HK. That's going to be the center of my circle. We're going to draw any segment R from a point HK to some point that's on the circle. So what I need is I just need a point out here somewhere that I'm going to call X and Y. I can put it wherever I want. For the sake of the picture and stuff right now, I'm going to put it right there. I could put it anywhere, but this is where I'm going to put it. And this is the point X and Y. And that point is on my circle. So with that, I'm going to draw my circle. So this is going to be the radius. Anytime I have the distance from the center to any point on the circle is called the radius. Using my compass here, I'm going to draw this circle, get it lined up. And so there we go. We have drawn a circle of radius R. So this is the radius that is R. Center HK, and that right there. So where does the equation for this circle come from? Some of you may even remember it, some of you may not. Well, in actuality, what it actually is this right here. It's the distance formula. The equation of a circle is a distance formula because the definition of a circle is all the points that are the same distance from a center point. And that distance will be R. Okay? So that means we could use the distance formula if you kind of remember that horrendous formula that you had back in the day. But where did that come from? That formula comes from the Pythagorean theorem. And so you look at this and say, well, Pythagorean theorem is for right triangles. I don't see that. But we're going to make one. What we're going to do is from this point, we're going to make a right triangle right there. So we're going to draw this length. And we're going to draw this length. Let me let you guys see what I'm doing. Into a right triangle as best we can. It may not be perfectly the right triangle, but that's what it's going to represent. So this is a right triangle. Straight across, straight down, 90-degree angle, right triangle. So the Pythagorean theorem basically says, if you don't remember it, let me just scribble it over here. It says in a right triangle with those side lengths, then the relationship between all three sides is a squared plus b squared equals c squared. So I have a right triangle. So what I want to do is I want to find that distance right there. And that distance right there. Well, to help us understand how that works, so there's a point right here. If we can find that point, we can find these distances. So remember, this is straight across that I used for a right triangle. And this is straight down, which means the y value on this line is exactly the same for all points. That means this point has the same y value as that point, which is k. And likewise, this line, which is going straight up and down, will have exactly the same x value for all points on this line, which means this point has the same x value as that point. And so that's what we have there. So that's the name of that point. Now, with that, let's talk about how we find distances on straight lines. I'm sure you all know a number line. And I will use the number 1 and the number 5. So if I ask somebody, what is the distance between these two numbers here on a number line, going straight across like that, I mean, most people just rattle off without even thinking about it that the answer is 4. But mathematically, how does that work? So using these two numbers, I simply take this distance is going to be the right one, this one on the right, minus the one on the left. So it'd be 5 minus 1. And that's where the 4 comes from. Okay? Well, what if I had it in the other direction? So how do I make sure, since it's a distance, that it is always a positive value? Because distances always have to be positive. I mean, whether I went this way minus 1, well, couldn't I have done 1 minus 5? If I went 1 minus 5 to find a distance, well, it's still 4 apart, but then you would get a negative 4 answer. So to keep these answers the same, because they represent the same distance, we do distances in absolute values, guaranteeing that my answer then will always be a positive value. So absolute values always makes a positive value because it represents distance. The absolute value actually means what is the distance between 5 and 1? 4. What is the distance between 1 and 5? 4. So that's how distances work. So taking this and expanding it up to this problem, what is this distance right here? Because I put this point over here, but I could have put that point anywhere on the circle, and this process still has to be true. So I have to make sure I always get a positive distance here. So to do that, I need the absolute values. So this distance is going to be the right one minus the left one. So it's going to be the absolute value of x minus h. That is that distance. That one number minus h gives me that distance, x minus h. And likewise, this one right here does the y values, so it'll be y minus k. And they're in absolute values because we want to make sure that the distance is always a positive value. Now that I have that, I now have all 3 sides of a right triangle. I can apply the Pythagorean theorem. So Pythagorean theorem says that this side length squared plus this side length squared is going to be that length squared. So I write those out. X minus h squared and y minus k squared must be r squared. Now, what's going on with this here? A lot of parentheses, a lot of little lines and stuff like that. And mathematicians don't like to be redundant and say the same thing twice. When I square a number, whether it's positive or negative, I will always get a positive number if I square a real number. The absolute value guarantees that this right here is going to be a positive number. So if I don't need the absolute values anymore if I'm going to square the value. So it takes care of itself because 4 squared is the same thing as a negative 4 squared. I get the same result. So they drop the absolute value parentheses for this, and they write this out as x minus h squared, y minus k squared equals r squared. And that is the generic formula for a circle. For a circle. And what do we know from this? We know that the center is the point h comma k, and the radius is r. So whatever that number is, you take the square root of it, that's your r, if it's in this formula. And so these are the things that we're going to be using right here to help us make the connection between circular stuff to right triangle stuff, which is the big part of this entire unit. So there's that right there. There's my equation of a circle. We're going to be doing a lot of circle stuff today, writing equations of circles and things like that. And so make sure you have that. You're going to use it quite often. All right, let's look at the next thing over here. Here's some definitions that you may or may not have known that we're going to be talking about in here also. We have the circle, the definition, which I said earlier, is the set of all points in a plane that are equal distance from a given point called the center. So that is the circle. There is the center. The radius is a segment whose endpoints are the center and any point on the circle. So I can do any point on the circle and connect it to the center, and that is a radius. A chord is a segment whose endpoints are on the circle. Okay? This is a chord. The diameter of a circle is a chord. In fact, it is the longest chord. diameter is a chord that goes through the center. It is also the longest chord. All other chords are smaller. This is a chord. As long as the two endpoints are on the circle, you have drawn a chord. Then we have the lines that we look through. Okay? A secant line is a line that goes through the circle in 2 points. And a tangent line is a line that touches the circle at 1 point. So this point right here would be called the point of tangency. Right there. And there's something important about the point of tangency that we're going to look at a little bit later also. Okay? Actually, you know what? I'm not going to give it to you right now. So, here's a couple things that you want to know that are important that you're going to use. Number one, the radius of a circle is perpendicular to a tangent of the circle at the point of tangency. And what that means is this. So if I draw the radius from the center to this point of tangency, then I know that this is 90 degrees. This is going to be perpendicular to the tangent line. That's an important concept you're going to want to remember. Okay? The other one is this. The perpendicular bisector of a chord of a circle will go through the center. Okay? That's another important one. So here's a secant. If I draw the perpendicular bisector, and I'm not going to actually find it, I'm just going to estimate it for you so you can kind of get the idea. So if I go about halfway and I draw this perpendicular bisector, you will see that this side length and that is exactly the same distance. Excuse me, I forgot to see it. So that piece and that piece from here to here and from here to here are equal. Okay, so from the points on the circle is perpendicular to the points on the circle of the chord. Okay, we're bisecting a chord, not a secant line. I probably should have drew it up there. But this perpendicular line right here will go through the center. Okay, this is how they do triangulation. If you ever watch movies and stuff like that, and they say, "Oh, we're going to triangulate with their position," this is how they're doing it. Okay, they get this, like a cell tower will have a radius that it can pick up signals. Okay, and then you need 3 towers. So here would be a tower 1, tower 2, tower 3. And if I do another chord over here, and I do a perpendicular bisector of that one, see? Between these 3 towers, I can find out exactly where you are. And that's how they do triangulation and find positions with your cell phones and things like that. So, little side note there, but there you go. So those are some definitions. We can talk about all the different identifiers in this little section right here. I'll save that one for a later time. And so let's look at some of these problems that we're going to be doing. So using the formula that I had over on the other side, and I'll write it over here so we don't have to keep going back and forth. Here's the equation, formula for a circle. So you're going to be asked to write equations of circles with given information. You need to know the center and a radius to write the equation of a circle. You need the center and the radius. So when you look to find the equation of circles, whatever information was given to you, those are the 2 pieces of information you have to find. And number 9, they were kind enough to give it to us. So 4 is h, 1 is k. We can plug this straight into our formula. X minus h squared plus y minus k squared equals 5 squared. So that's the formula. You could also just have written 5 squared as 25, which is more appropriate for our answer. There you go. You wrote the equation of the circle. What if I gave you a circle drawn and I gave you the point where the center is? Well, from your graph, hopefully you can find the name of the center. In this particular case, we are going over -2, -3, and then -2. So that's my center. And now from my picture, I need to find the radius. Since the radius is from the center to any point on the circle, the quickest and easiest direction to go is either up and down, left or right. So what is this distance from here straight across to that edge of the circle? Well, the edge over here is at 6. This over here is -3. So that's a distance of 9. So that tells me R is going to be 9, and that is my center. And so now I can write my equation. It is x minus a -3 plus y minus a -2 equals 9 squared, 81. And that's how that works. Now, what about this one? Here, they gave me the center, but then they gave me a point on the circle. Well, I have to find the radius. Okay, so one technique that is very useful to try, and you don't have to do this on graph paper, but you should draw a sketch of this. It doesn't have to be perfect, doesn't have to be even to scale, but you should draw a little quick sketch to kind of see what this is going on. I did set it up on graph paper so you can see what I'm talking about, but you can literally draw this very, very quickly. So this point right here is the point 1, 2, and this is the point 4, 2. Okay, but I could have drawn it just like this. I would have gone right over here, 1, 2, 4, 2. Oh, okay. See, I can see it there also because I just need that distance right there. And they're horizontal from each other, which means it's very easy to see the distance. It's going to be 1, 2, 3. So I have a radius that is 3. The center is at 1, 2. And so now I can see clearly what to plug in. X minus 1, y minus 2. 3 squared is 9. Now, the most common mistake people make is they forget to square the radius. Sometimes they'll just put 3 here. Remember, you need to square it. So if it helps you to write 3 squared and then rewrite it with it and square it afterwards, that's great also. The other mistake people make is the other direction, like this one. They'll see a 9 here, and they'll say the radius is 9, forgetting that this is r squared. So you need to be very careful with this, okay? This question right here is asking you to use the given equation in the line to show 2 methods for determining whether the line is tangent or secant. Okay, so what does this mean? The line is tangent. That means these 2 things will touch at 1 point. And if it's secant, then they would touch at 2 points. So what methods do I have? Well, the first method, hopefully you all thought of it, is to simply graph it. So we can graph this information on the same coordinate system and see, hopefully, whether it crosses once or twice. Okay? But a graphing technique is not very accurate. You have to be very accurate in your graphing or you'll make a mistake and you'll assume one thing over the other one. The other technique is to solve it algebraically. And I will show you how to solve it algebraically also. But here's a graphical thing that you can do very quickly to kind of see whether or not, if it's obviously going to be tangent or secant. So the circle had a center. Let's put it back over here. So the circle had a center at HK. H is x minus h, so this is going to be at 4. And this number over here is 3. If you're not sure what those numbers are, just think of this. What makes the stuff in the parentheses 0? X minus 4, you go off to the side. X minus 4 equals 0, so x equals 4. That's my h. Do the same thing for the y one, and you'll see that k is 3. My radius is 3, the square root of 9. So we're going to graph the circle, and then we'll come back and graph the line. So I have a center at 4, 3, 4, 3. and a radius of 3, which means it's going to go through 1, 2, 3. Okay, 1, 2, 3, 1, 2, 3. It's going to go through all these points right there. And so I just need to get my compass, and we will draw that out. So did I find it? No, it's really, really small. And I will do the best that I can with my picture. I need a little bit more. And I missed. But you get the idea. So I have a bad compass on that one. But there's my circle. I got to draw it again because I have to be as accurate as I can. And that compass failed me. Let's see if I can get it again. Let's try again. No, it's not working for me. I am off somehow. So I'm going to kind of freehand draw this up. For the sake of the video, I'll get better compass than this one next time. All right, we're going to graph the line. Y equals negative 3x plus 6. So that would be a dot here. And then we can do the slope of down 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And then if I connect those dots like so, I can see pretty clearly, as long as everything was done properly, okay, that it's probably going to go through 2 times. Okay, so then this would be a secant line. A secant line. Okay, I apologize for the circle being horrible, but there's that. We'll use a better compass, and that one, it was just too small for that. So how do I solve this algebraically? The only method that you can have for solving algebraically is you have to do substitution, which means this is y. You're going to substitute this quantity into this equation for y. So this is what you will write. X minus 4 squared plus, parentheses, this y right here is a negative 3x plus 6 minus 3 squared. So that's what that is. See, y minus 3. The y minus 3 squared equals 9. Clean all this up in here, combining like terms and stuff like that. And then this right here is going to be negative 3x plus 3 squared. And now you need to multiply these two things out and then combine like terms. So this is going to be x squared minus 8x plus 16. And this one over here, same thing. We're going to then take this and we're going to get 9x squared minus 18x plus 9, and then that's a 9. So this is all going to be quadratic stuff. Bring everything together on one side. That plus that is going to be 10x squared. That plus that is going to be minus 26x. Okay, this is a 9. I have to subtract the 9 to get a 0 over here. So that 9 is gone, and I'm left with just plus 16 equals 0. These are all even numbers. So I'm going to divide everything on both sides by 2. And so then I get 5x squared minus 13x plus 8 equals 0. Makes it a little bit easier to solve. Okay, we're going to try and solve this. Let's see if we can factor this. We have factors of 8 and 5. 1 and 8, and 2 and 4 that are going to add and give me a 13. Well, I can do the 5 and the 8 will give me 13. So 1 times 8, 5 times 1. Okay. So I have a 5x and an x. The 8 and the 5 cannot multiply, so this has to be the 1, and this has to be an 8. and they both have to be minus signs. So from this right here, we can see then that 5x minus 8 equals 0, or x minus 1 equals 0. And so x equals 8/5, or x equals 1, indicating that we have two solutions to this system. Okay? Because we have two solutions to the system, and we can kind of look at it here. I got kind of close. Looks like the first one is going to intersect here at 1, and the next one is at 8/5, which is 1 3/5. So right about here, 1 3/5. Even though I have a horrible circle, pretty darn accurate, sort of. Okay, so there you go. These are some things that you're going to be asked to do using the equation of a circle. And with that, we will end the video.